Okay, let's continue the discussion of a quadratic equation. Last time we talked about the factorization of a quadratic equation and then apply the zero product property. This time, let's introduce another method. It's called the square root method. The square root method. Okay, what is the square root method? Let's see this type of a quadratic equation. X squared is equal to p. P is a non-negative number. Here we require p is non-negative. If p is negative, this equation has no solution. Okay, so that's simple. So this actually corresponds to the case when the b is equal to 0. Remember that ax squared plus bx plus c. When this number b is 0, coefficient b is 0, this middle term disappears. So you will only have ax squared plus c equal to 0. You see, if you just move c to the other side, divided by a, that's exactly this, right? So this square root method works perfect when the coefficient b is equal to 0. Right? Okay, so what is the solution for this? We all know that if a square of x, the square of x is p, then x is square root of p, or x is negative square root of p. There are always two square roots. One is positive, the other one is negative. Okay, so we completely solve this problem. So the strategy for the square root method is that for x squared equal to p with the condition p greater than or equal to 0, x is square root of p or x is negative square root of p. So this is a conclusion. And this is called the square root method. For example, if you have x squared equal to 4, then x is square root of 4. Square root of 4 is 2. This is a simple number. Or x is negative square root of 4. Negative square root of 4 is negative 2. Okay? And you will not always have this complete square number. So if you have x squared equal to 5, then x is positive square root of 5, or x is negative square root of 5. So they are the final answer. There's no way to simplify square root of 5 and the negative square root of 5. All right. Let's make this example even more complex. The advantage of a square root method is that the left-hand side is square, right-hand side is a positive number. It's not always true that the left-hand side is x squared. It could be something else squared. So for example, if you know x minus 2 squared is 16. X minus 2 squared is 16. What do we do? Just consider this left-hand side as a one quantity squared. It is equal to 16, then x minus 2. This is one quantity. It is positive square root of 16, which is 4, or x minus 2 is negative square root of 16, which is negative 4. Right? So you just consider this whole thing as one quantity. And then you solve this linear equation. X minus 2 is 4, then x is 6. Or x minus 2 is negative 4, x is negative 2. So the solution set will be 6 and a negative 2. Okay, so when the left-hand side is some quantity squared, not just x squared, you should first consider this quantity as one thing and apply the square root method. You have either positive square root or negative square root, and then you solve the rest of the simplified problem. Okay. Okay, so this gives us an idea. If we have this type of formula, this type of equation, we can solve it. Now let's see how do we get this type of a quadratic equation. We solve a quadratic equation by completing the square. We're going to do it by example. For example, we solve by completing the square. X squared plus 5x plus 4 equal to 0. Okay, so we emphasize we just want to use this method. How do we use this method? Okay, there are fixed steps. So first, let me copy this formula, equation. When you have this quadratic equation, the first step, you always move this constant term to the right-hand side. You move it to the other side, it becomes negative 4. Here's positive, and it becomes negative. And then, what is a completing square process? Let me recall the formula. Remember, when you have x plus a, the quantity squared, it is x squared plus 2ax plus a squared. This is multiplication. If you read from left to side, it's a multiplication. But if you read from left to right, it's a multiplication. If you read from right to left, it's a completing square process. So you see, you write the sum of 3 terms into the quantity squared. Okay, now let's check. You have x squared here. You have 2ax. So I need coefficient 2, but this number is 5, so 5 over 2 and times x. So by this multiplication, you see that x squared 2ax. So this quantity should be a. And then you need a squared. So this term, okay, so here this term comes from this 5. So 5 over 2 times 2 is 5. And this term comes from nothing. There's no such term. So in order to still get the equation, add this number on the right-hand side. Add this number. See here, the left-hand side you add this number, the right-hand side you also add this number to balance it. This number over 2 times 2 is still 5. Negative 4 is here. X here is x here. And then you consider the sum of those 3 terms. It becomes x plus a quantity squared. So it's x plus a. What is a? 5 over 2 quantity squared. So here it is negative 4 plus 5 over 2 squared is a 5 squared. Okay, a over b squared is a squared over b squared. So it's a 5 squared, 25, 2 squared, 4. Okay, you see how I computed them? This process is called the completing square, completing the square. You miss some term, you add it. You add it to the left-hand side, you also add it to the right-hand side. And here you artificially factor out the number 2. You factor number 2, you have to divide by 2 to balance it in order to get the original coefficient of 5. Okay? Okay, so negative 4 plus 25 over 4 is a negative 16 over 4 plus 25 over 4 is 25 minus 16 is 9 over 4. So the right hand side is 9 over 4. Nine over 4. 9 over 4, you will see that it's a 3 over 2 squared. It's a complete square. It's a good number. Okay, so now this formula is like the example here. You have a quantity squared is equal to a positive number. Then you apply the square root method. You will get x plus 5 over 2 is square root of 9 over 4, which is a 3 over 2, or x plus 5 over 2 is negative square root of 9 over 4, which is negative 3 over 2. If you are familiar with the square root operation, you can skip this middle step. But if you are not, just write them to remind you how you get this 3 over 2. 3 over 2, okay? Okay, so from here, x plus 5 over 2 is equal to 3 over 2, then x is equal to 3 over 2 minus 5 over 2 is equal to negative 1, or x is equal to negative 3 over 2 minus 5 over 2 is equal to negative 4. Okay, so the solution set is negative 1, negative 4. You can check it. It is negative 1, negative 4. Okay, so this is the solution of a quadratic equation by completing the squares. Okay, and by the way, this one we can factor it. We can factor this. So x squared plus 5x plus 4 is equal to 0. This coefficient of x squared is 1, so you factor it as 1 times 1. 4, you factor it as 1 times 4. You do the cross multiplication. 1 times 1 is 1, 1 times 4 is 4. So the sum is 5. That's exactly this 5. So you put x here, x here. So you get x plus 1, x plus 4 equal to 0. Then by the zero product property, so either x plus 1 is 0 or x plus 4 is 0. So here x is equal to negative 1, x is equal to negative 4. See, the same answer. Different method, but you should have exactly the same solution. Okay. Okay, let's continue this. This problem, it seems that the factorization method is much simpler and shorter than the completing square method. But sometimes a quadratic equation may not be able to factor it easily. Then you will have to use this completing square method. So for example, solve this 2x squared minus 8x minus 5 is equal to 0. You can try it. Here's 2, here's negative 5. You try whatever factorization, you may not succeed. Okay? The integer factorization. You cannot get the answer. Okay, so let's try the completing square method. The completing square method is better for you to have x squared solo. I don't like this number 2 here. Okay, so I don't want the number 2 here. The coefficient 2 is not interesting in the computation. It will make the whole computation more complex. Okay, Since here there is a coefficient 2, we're going to divide this equation by 2. Divide the equation by 2 means all the terms should be divided by 2. So 2x squared over 2 is x squared. 8x over 2 is 4x. 5 over 2 is 5 over 2. Okay? And then we're going to move this constant number to the right side. Okay, we move this 5 over 2 to the right side. Here's minus, move to the right side, it's a plus. And then we're going to complete the square. Recall how do we do that? How did we do that? We need artificial 2 minus 2. And then here's 5, 5 over 2. Here's 4, 4 over 2 is another 2. Okay, and this place you just get this second number, second factor squared. So the second factor here is 2 squared. The right hand side you copy 5 over 2, and here you add 2 squared. On the right hand side you also add 2 squared. Okay, so that's a completing square process. And in this formula, if this middle side, the middle term, let me write it. If this middle term has a positive sign, this is a positive. If this middle term has negative sign, only middle term, if it has a negative sign, then this is x minus a squared. Okay, so there are two formulas for the completing square. One is for the positive, one is for the negative. So here's a minus 2 times 2x and plus 2 squared. So in this formula, a is number 2. So the left hand side becomes x minus 2 quantity squared. Right hand side is a 5 over 2 plus, well, what is this? This is 4. 5 over 2 plus 4. A 13 over 2. 13 over 2. Okay? So now we're again back to the good position. A quantity squared is equal to a positive number. Then we have either x minus 2 is a positive square root 13 over 2, or x minus 2 is negative square root of 13 over 2. Right? So once you get a quantity squared is equal to a positive number, you automatically get a positive square root and a negative square root. Right? And then you continue to solve it. You move 2 to the other side, you will get x equal to 2 plus square root of 13 over 2, or x is equal to 2 minus square root of 13 over 2. Okay, so the solution set is 2 plus square root of 13 over 2 and 2 minus square root of 13 over 2. And that's it. That's it. Okay, understand this? So this two problem gave us two examples gave us two formulas, depend on two formulas. One is for the plus, one is for the minus. And in the final answer, you can just leave it like this. You don't have to simplify it. In the textbook, they provide a way to simplify it. It's not necessary for our class. Okay, you can just leave it like this. The simplification is the following. I can teach you, but it's not necessary. For example, let's choose this one. Sometimes people do not like square root of a rational number. They just want square root of integers. How do we do that? 13 is a prime number. 2 is a prime number. There's nothing we can move. They're both complete square, perfect square. So we are going to do the following trick. So we multiply top and bottom by 2. a duplicate. Then the numerator becomes 26, denominator becomes 4. And for the square root of a rational number, square root of b over a, if a, b are both positive, it is a square root of b over square root of a. You can break the square root to the top and to the bottom. So, and square root of 4 is 2. That's how they get this number, square root of 26 over 2. You see here, now under the square root, there's only integers, and over an integer 2, but this 2 is not inside the square root. It's different. Okay, so that's a way to simplify it. So for example, let's try one more. Whatever stuff, if you cannot move it outside of square root, you're going to multiply top and bottom by a duplicate copy. You multiply top and bottom by 3 by the denominator. We want to move denominator out. We don't want to move the numerator out, remember. Okay, and then you will get the square root of 3 over square root of 9. Square root of 9 3. So you will get square root of 3 over 3. It is equal to square root of 1 over 3. This is the steps they use. Okay. Well, that is how we solve the quadratic equation by completing square. We have this fixed step. First, if the x squared term has a coefficient, we divided the whole equation by this coefficient. We just want x squared solo. We don't want any coefficient. And second, you're going to move the constant number to the right-hand side. Only this number term, not other terms. And second, you need an artificial number 2, and then the original coefficient over 2. 4 over 2 is 2. And then you're going to add this quantity, this middle term squared, for 2 sides. Don't forget the term, the addition on the right-hand side. And then you simplify the right-hand side, you write one number, you find a one number. And the left-hand side, by the completing square formula, it is either x plus a squared or x minus a squared. X plus or minus a squared is equal to a number, then you take square root. You have a positive square root, you have a negative square root. And you have two linear equations, you move the constant number again to the right-hand side, you will find the final answer. There are always two final answers. Sometimes those two answers are repeated. It is possible. Okay? It's possible to have repeated final answer. If this number is 0, positive square root 0, negative square root of 0 are both 0. In that case, you will see repeated terms. Okay? Repeated roots. Okay, so this whole process is such a fixed process. Whenever we have fixed process, technically we can program it. Once we program it, we will have a formula. Now let's make this program readable, okay? Let's see how we do that. That's 3. Solve a quadratic equation by using the quadratic formula. Okay, so we need the quadratic formula. Let's go through this slowly. We have this standard form quadratic equation, and always we assume this a is not 0. A is not 0. Okay, So what did we do? The first step, we divide the equation by the coefficient of x squared. So we divide all the terms by a. Okay, we divide everything. So we just, technically we just copy those steps, but we need the letters instead of numbers. Okay, and then we move this constant term to the right side. We move it to the other side. Here's plus, then this one becomes minus. Then what's else? Next, you're going to artificially, you see here, artificially you need a coefficient 2. And then you divide this quantity, b over a by 2. b over a over 2 is b over 2a. b over a over 2 is b over 2a. Okay, so b over 2a. And this is the term you're going to square. So you add b over 2a squared on two sides. Right? So here, those two terms are artificially added. Here, this term comes from b over a over 2, and then times 2. 2 to cancel, you still have b over a. Negative c over a is copied. Okay? So we do exactly the same thing as the previous example, but we just use letter. They look very strange or abstract. It doesn't matter. Just follow the step. And then the left-hand side becomes x, here's plus, x plus this quantity. So it's x plus b over 2a squared. Plus or minus is totally determined by this coefficient. This coefficient plus, you put a plus. This coefficient is minus, you put a minus. On right-hand side, so b over 2a, again, you distribute this square into the top and bottom, so you will get a b squared over 2a squared is 4. 2 times a quantity squared is 4 times a squared. Okay, and now we are going to simplify this part. We're going to simplify this part. We simplify this part. Let's try to add them. So negative c over a. Here is a 4a squared. Here's a. So we multiply top and bottom by 4a. 4a. b squared over 4a. So it is equal to 4a. Denominator is 4a. Numerator is b squared minus 4a and c. Okay, so the right hand side is b squared minus 4ac. Now we have some discussion. If this quantity is negative, if this right hand side is negative, a square is not equal to a negative number. And this ratio is negative. Denominator is positive. 4a squared is always positive. So the ratio is negative means the numerator is negative. So if the right hand if the right hand side is negative, the equation has no solution. Okay? If the right hand side is negative, we already discussed that the denominator is positive, the ratio is negative, then the numerator is negative, i.e. b squared minus 4ac is negative, the equation has no solution. Okay? When this numerator is negative over a positive number, the ratio becomes negative, then equation has no solution. This is the bad case. Okay, so we want a good case. We want to know when it has solution, how do we solve it? So here we assume that from now on, b squared minus 4ac is non-negative, greater than or equal to 0. If it is greater than or equal to 0, we are going to take square root. We take square root, the left hand side becomes x, and there's no parenthesis, x plus b over 2a, and right hand side you take square root. When you take square root, you're going to move 4a squared outside, it becomes 2a squared, 2a. And this place, 4 you move it out, it's automatically 2a. But a squared, when move it out, it is not exactly a. So in order to make the discussion simpler, let's assume this a is a positive. Assume a is a positive. We want some simple discussion. When a is a positive, you get 2a. Okay? So you have a positive square root or you have a negative square root. Okay? So we will recover the case when a is negative. Okay, then you move this b over 2a to the right side, b over 2a to the right side, you will get x is equal to negative b over 2a plus square root of b squared minus 4ac over 2a, or x is a negative b over 2a minus square root of b squared minus 4ac over 2a. And they both have denominator 2a, so let's continue the writing. Just be patient. We will just only do this once, and then later we will memorize the formula, ignore the steps. So it's negative b plus square root of b squared minus 4ac, or x is 2a negative b minus square root of b squared minus 4ac. They have the same denominator. Addition just means addition of a numerator. Okay, so those two formulas are almost identical, except here's plus, here's minus. This plus and minus sign come from the positive square root and the negative square root. Okay, so put them together, we have the quadratic formula. Quadratic formula is you have two roots. Negative b plus or minus square root of b squared minus 4ac over 2a. This is a quadratic formula. Okay? And you can do that under the condition b squared minus 4ac greater than or equal to 0. If it is less than 0, no solution. You don't have to do anything about this. Okay? So that's a formula you are going to keep in mind. Be careful. It's very, very, very important. Okay? So this formula, we get this formula, also have a small restriction. We require a is positive. let's discuss what happens if a is negative. Why do we require a is positive? We move negative 4a squared outside. We move this a squared outside. We need this a positive. If a is negative, remember here, when we take square root, we take square root of this whole thing. You need to compute square root of the numerator and the square root of the denominator. This is a square root of the denominator. Okay, when a is negative, let's 2 is already moved out. For example, a is negative 2. Then square root of a squared is square root of negative 2 squared. What is this? It's a square root of 4. It is equal to 2. 2, what is 2? 2 is negative a. A is negative 2, then 2 is negative a. So when you have a negative number, square root of a squared is equal to negative a. So when you have a negative a, you get negative 2a. Negative a give you negative 2a. This number is positive. Because a is negative, with negative sign, it becomes positive. Flip the negative number to be a positive number. Okay, in this case, the denominator here is negative 2a, so square root of b squared minus 4ac, negative 2a, or x plus b squared minus x plus b over 2a, negative square root of b squared minus 4ac over negative 2a. So this discussion only changes the denominator. Here the denominator is 2a, here the denominator is negative 2a, but you still have positive square root and a negative square root. These positive and negative signs are not related to a, they are related to the square root process. Okay, and you cancel this negative negative, you will get positive. There's a positive sign, but this number is a negative number. 2 times a negative number is negative number. So you see, you actually have the same formula. X plus b over 2a is, here you have negative sign. X plus b over 2a, there's no negative sign. It's exactly this. So from here, you will get the same formula. So it doesn't matter you have a positive a or you have a negative a. Your quadratic formula will be the same thing. Okay, so don't worry about the sign of a. You will have a unique quadratic formula which will give you usually 2 solutions. Okay, it does not matter if a greater than 0 or a less than 0. You have the same quadratic, formula. Okay? Okay, now let's continue the discussion of this quadratic formula. Remember here, b squared minus 4ac less than 0. So we are going to have several discussions. When this quantity is less than 0, no solution. When this quantity is equal to 0, when this term is equal to 0, then 0 over 4a squared is also 0. So the right hand side becomes 0. A quantity is 0 if and only if this part is always 0. The left hand side, 0 squared is 0. Only 0 squared is 0. So there's only one solution or repeated solution. A repeated root x equal to negative b over 2a. because this term disappear. You add 0, subtract 0, you still have 0. So you have just a repeated root. X is equal to negative b over 2a. You see here, this is 0, this is 0. Those two parts are both 0. You have negative b over 2a, negative b over 2a. A repeated roots. 3. If b squared minus 4ac is greater than 0, two different roots. So when you really have b squared minus 4ac positive, strictly positive, you have two different roots. And this quantity is extremely important in the quadratic equations. It has a name. It's called b squared minus 4ac is called the discriminant. The discriminant. Keep this word in mind. Discriminant is an important quantity for the quadratic equation. It will give you three different cases about the solutions. All right, so be careful. This quadratic formula comes from that completing square method. We just make this abstract. We already did the example, the detail, the concrete example in detail. When you have a number, you will see the numbers. You don't see this b squared minus 4ac. That's complex stuff, but they actually go through the same steps. Okay. Now let's see the examples. If you have 3x squared minus 5x and plus 1 equal to 0, we're trying to use quadratic formula to find it. So quadratic formula, ax squared plus bx plus c. A, B, C contain the sign. So here a is 3. B is negative 5. When you have negative sign, the b contains a sign. B is negative 5 and c is 1. Whenever you're trying to apply the quadratic formula, you need to examine the discriminant. Examine the discriminant. B squared negative 5 squared 25 minus 4 times a times c is 25 minus 12 is 13. Okay, it's positive, so the equation has two different solutions. What are two different solutions? X is, what's the formula? Denominator 2a, 6. Numerator negative b. B is negative 5. Negative b is 5. Plus or minus square root of b squared minus 4ac. We just computed. It's a 13. We copied it 13 here. Okay, so plus or minus means you have two solutions. X is 5 plus square root of 13 over 6, or x is 5 minus square root of 13 over 6. Okay, so the solution set is 5 plus root 13 over 6, 5 minus root 13 over 6. And that's it. That's it. Okay, you see how we apply this quadratic formula. And next, let's see next example. Next example, we have 25 over 2 times x squared minus 30x and plus 18 equal to 0. So here a is 25 over 2, b is negative 30, and c is 18. Be careful about the sign. All the a, b, c contain the sign. They are positive, negative. It depends on this coefficient. So first, we examine the discriminant. B squared, negative 30 squared, 900, minus 4ac. You check that 4 times 25 over 2, you cancel 2, you have 2. 2 times 25, what's 2 times 25? 2 times 25, 50. 50 times 18, 900. So 900 minus 900 is 0. The discriminant is equal to 0. Discriminant is equal to 0. The equation has a repeated or double root. Okay, it has a double root. What is a double root? X is equal to negative b over 2a. The double root, x is equal to negative b over 2a. Okay, so what is that? B is this negative sign is part of a system, and b is a negative 30. Copy negative 30. 2a, 2 times a is 25 over 2. All right, so it's a negative negative cancel. The numerator is 30, denominator is 25. 2 cancel. 30 over 25. You cancel 5, you get 6 over 5. So the solution set is 6 over 5, and that's it. Okay, so we know it's a double root. It will be doubled when you count the solutions, but when you write the solution set, there's only one number. Okay, let's see another example. Okay, this is 3x squared plus 2x and e is equal to 4x. 3 squared plus 2x is equal to 4x. The quadratic formula can only be applied to the standard form quadratic equation because we need the a, b, and c, correct value of a, b, c. A, b, c are only appear in the standard form. So here 4x, you have to move 4x to the left-hand side. Okay, then you know that the a is a 3, b is a negative 4, and c is a 2. You check that first discriminant, b squared minus 4ac. b squared, b negative 4 squared, 16 minus 4a and c. 3 times 2, 6. 4 times 6, 24. It's negative 8, less than 0. Wow, that's good news. The discriminant is negative. The equation has no real solutions. You don't even to apply the quadratic formula. There's no quadratic formula. Discriminant negative, no solutions, no real solutions. So you stop. That's what I say. You have good news, but usually you will have positive discriminant. All right. So that's it. This problem is done. Okay, so sometimes the equation at the beginning may not look like a quadratic equation, but with a small modification, very quickly you will see it is a quadratic equation. If you have equation 9 plus 3 over x minus 2 over x squared equal to 0, x is not 0, then this is not a quadratic equation. This is in the denominator part. Quadratic equation definitely is x squared, but it's not in the denominator. So, but here we multiply two sides by x squared because x is not 0, x squared is not 0. So we multiply the equation by x squared. Then we will have every term times x squared. So 9x squared plus 3x, here one copy of x cancelled, minus 2 is equal to 0. Okay, so now you have a quadratic equation with a equal to 9, b equal to 3, and c equal to negative 2. Be careful, c is equal to negative 2. Okay, then you check discriminant. B squared is 9 minus 4ac. So negative, negative, a positive. 2 times 8 is 2 times 9 is 8. 8 times 7 is 8 times 9 is 72. 8. This 2 times 4 is 8. 8 times 9 is 72. Minus minus plus. So 9 plus 72 is 81. Is 81. All right. So b squared minus 4ac is 81. Positive, it will have two different real solutions. Okay, so the x is 2a negative b plus or minus square root of b squared minus 4ac. That's way how we recycle this quantity. This quantity is exactly the quantity under the square root. And square root of 81 is 9. Square root of 81 is 9. So we have two solutions. So x is negative 3 plus 9 over 18. Negative 3 plus 9 is a 6. 6 over 18, 1 over 3. Or x is equal to negative 3 minus 9 over 18. It's negative 12 over 18. It's negative 2 over 3. So the solution set is 1 over 3, negative 2 over 3. That's it, and that's it. Okay, so this is the abstract discussion about quadratic equations. We finish this video now, and we will continue the discussion of this section, one of a word problem, in the next short video. Okay, so do the exercise. Make sure you can apply the quadratic formulas. It's a little bit complex, but do several examples. You may memorize it. If you have questions, send me email. Okay, we'll stop this video. We'll continue in the next video. Thank you.